All right. Well, good afternoon, everybody, and welcome to our Shape Your Future session for today. Shape Your Future is our Careers in STEM webinar series brought to you by the Australian Academy of Technological Sciences and Engineering, or ATSE, as we like to call it. My name is Graham Stock, and I'm the STEM Education Manager here at ATSE, and I'm delighted to be leading you through today's session, coming to you from beautiful Ngunnawal country here in Canberra, the nation's capital. And we're deeply privileged to live in a country which has been continuously inhabited and under the continuous custodianship of some of the first scientists, technologists, and engineers for more than 60,000 years. And I'd like to begin today by paying my respects to Aboriginal and Torres Strait Islander people from across Australia and to acknowledge both elders past and present from whatever part of country that you are joining us from here today, as well as welcoming any Aboriginal or Torres Strait Islander peoples who may be joining us for the session. So for those of you who may not know, ATSE is one of Australia's 5 learned academies, and we have over 900 fellows within the academy. And the goal of the academy is to provide expert advice to government and decision makers on STEM and STEM education in Australia, as well as supporting students and teachers like you guys engaging at home with STEM learning and the amazing future pathways that exist in STEM, particularly here in Australia. We also support programs and student educators through our Stellar STEM education program, which Shape Your Future is a part of, as well as some other things that we do. And we have some other programs like Elevate and IMNIS to support students entering and leaving university. And I'd encourage you to explore these wonderful programs more through our website and get in touch with us if you have any questions about those. A little bit about me before I start. I've been a science, maths, and design and technology teacher for the past 10 years here in the ACT. I've championed a range of extracurricular programs, including RoboCup and F1 in schools, and I've led students to represent Australia internationally at some of the largest STEM competitions in the world. And Australian students always do some of the best jobs in STEM competitions of any students in the world. So we've got a lot to be proud of here in Australia. I'm also the Australian International Representative for RoboCup Junior Australia, the chair of RoboCup Junior here in the ACT, and an honorary fellow of Re-Engineering Australia Foundation. And it's my absolute pleasure to be leading today's session. Our theme is Beyond the Orbits, A Journey Through Space, which is something close to my heart as well. I did ion thruster research when I was at uni before transitioning into teaching. So I'm really excited to hear about this growing industry, and some of the fantastic presenters we have today are going to tell us all about their careers, their relevance in Australia, and the diverse paths that have led them to where they are today. Before we start, though, we just have a little bit of housekeeping to get through. So I'd like to remind everyone that's attending today that you have agreed to abide by ATSE's Code of Conduct, which means you'll behave respectfully in all aspects of the session today, including in the Q&A channel, where you can drop questions if you have any. I'd like to remind you the session is being recorded and will be made available on ATSE's YouTube channel in the coming weeks. So if you have any colleagues or fellow students that would love to see some of the information today but didn't get a chance to come along, please make sure you share that with them. And obviously, this is an interactive session. We've got a bit of time when we're going to hear from each of our speakers, but we want to hear from you and answer any of the questions you may have. So make sure you jump into that chat at any point during the session today, and during our Q&A at the end, we'll try and answer as many questions as we can get to in the time we've got. Now, it's my great pleasure to introduce 3 fantastic speakers that we have today. I'll give them a brief introduction now, and then I'll introduce them in a little bit more detail when it's their turn to speak. But they're going to be exploring their career journeys in STEM today. And reflecting on the choices that led them to where they are, the influence on technology on their career pathway, and how collaboration and problem solving helps them in their day-to-day work. So our 3 incredible presenters are Dr. Laura McKemish from University of New South Wales, who is a senior lecturer in quantum chemistry and a molecular physicist. We have Dr. Namal Kumar Balasubramani, who is an aerospace engineer specializing in design and development of composite materials and structures at OmniTanker. And we've got Dr. Lucy Foreman, who's a planetary geologist at Curtin University and a research associate in the meteoritics at Western Australian Museum as well. So thank you so much for joining us all today. I'm sure we'll be really excited to hear from each of you. First and foremost, though, we have Dr. Laura McKemish. So Laura is a senior lecturer at the University of New South Wales. As a quantum chemist and molecular physicist, Laura specializes in using theoretical and computer simulations to model molecules to study how they absorb light, also known as spectroscopy. This is critical information that allows astronomers to understand chemistry in the universe, with Laura's work helping astronomers interpret data from the James Webb Space Telescope, which I think is just awesome. So Laura, thank you so much for joining us today.
Thank you very much for having me. So I was obviously once a student like you guys, and I've been asked to talk about my career journey here. And I would say that from a very young age, I was into astronomy, I was into spectroscopy, which is the study of how molecules absorb light. I was really into quantum mechanics as well, which is all about how do atoms, electrons, nuclei all come together and do things. And I would say my career journey has been more linear than most, because it sort of started where I've ended up now. But I just wanted to take you through a few highlights as we were. One thing I did participate in as a high school student was the International Science and Engineering Fair, which was incredible and awesome. And I thought it was the first. I used to swim as a kid, and swimming got me all the way to Perth, and I thought that was pretty cool. And then I did science, and that got me all the way to Arizona to see the Grand Canyon, and I thought that was even cooler. So science seemed like a good thing to do. That was my one experimental project. I had wind turbines and was figuring out how do you make wind turbines most effective. And then I went to university and realized that at university, I did a Bachelor of Advanced Science at the University of Sydney. And I took part in what's now called research integrated learning, which means you can do a research project as an undergraduate. So I actually was doing research from my first year of undergraduate. I did projects in all sorts of things, from astronomy, spectroscopy, but I also got in the lab and made a molecule that no one had made except me. I went into a laser lab where we had big expensive lasers and shot things and figured out experimentally how molecules absorb light. And then I decided I was a theoretician. And so I did some bioinformatics, some quantum chemistry, some quantum computing, which is basically take our modern computers, and the next generation of computers might be, instead of being based on a 0 and a 1, which is our modern computers, they might be based on quantum principles, which are really cool and really powerful. So maybe we'll get to those in a few years. I know UNSW and many other places are doing some incredible work in that space. So I did 3 years of undergraduate, and then I did a year as a honours student where I was researching quantum chemistry and quantum computing, so actually mixing those two fields. Then I went to Canberra at the Australian National University and did a PhD in. A PhD, basically, for those of you who don't know, means you spend 3.5 years of your life becoming a world expert in something. So I am a world expert in how you describe molecules computationally. Very theoretical, but was a good time. So that's the image here where we've got, this is called the Schrödinger equation, and that basically describes electrons and molecules. We put them in a computer and off we go. And then after that, I went to London for 3 or 4 years. So this is where science can take you, all over the world, and did a lot of different trips there. And that's where I got into the field of helping astronomers understand what molecules they'd found in planets. So the big application that you guys have probably seen on this is, you know, those news articles you read and they say, we've found life on this planet, or we've found water or carbon dioxide or methane or whatever it is. My science, and that's what I learned in London, my science helps enable that discovery. And so since 2018, I've been back at UNSW building my research group. So I've now got PhD students of my own. And they're really focusing on helping astronomers understand the planets that they're looking at. So when I was born, we didn't know that there were planets around stars other than our own. So they're called exoplanets. And now we've found 5,500 plus of them. And now we're starting to say there's water, there's this physics, there's this chemistry, maybe there's this biology. But one of the big things in my research group is probably don't trust yet the article that says we've found life. We probably haven't found it yet. Maybe in 30 years we'll get there. And the other big part of my job that I wanted to briefly mention is I had a fantastic time as a student, and I think it really benefited my career to be able to get work with researchers from quite a young age, and pursue all sorts of different research projects. And so now as an academic, I'm actually involved in something called the SciEx program, where we bring about 200 year 11 and 12 students onto campus each year, and they do a research project in anything from bioinformatics to making medicines to marine biodiversity, all these different subjects. So I really enjoy that. And I would encourage you, whatever your, there's lots of opportunities, far more than there was, 20 years ago, to actually engage with the scientific process quite early on, and just keep an eye out. And you've done a lot of that by coming along to this webinar. So thank you for coming along. Was that basically what you were looking for, Graham? I hope.
Yeah, Laura, that's perfect. Fantastic. Like I know my students were always really fascinated by those articles about, we found a planet where it rains diamonds and things like that. So it's interesting to hear your work on it. I think it's really cool. And I hope in the Q&A we can unpack a little bit more about the suggestion you had at the end there about kids getting into, researchers and in industry really early and seeing the pathways they can have. That's great. So thank you so much for that. That was fantastic. Right, so our next speaker is Dr. Nimel Kumar Balasubramani. So Nimel is an aerospace engineer specializing in the development of lightweight carbon fiber reinforced polymer composite structures for space and terrestrial applications, which sounds so cool. He's also an ambassador of ATSE's Industry Mentoring Network in STEM program, or IMNIS. Nimel commended his PhD at UNSW and currently works as a design engineer for Omni Tanker. And he's got 4 years of industry experience designing cutting-edge carbon fiber pressure vessels and precise motion control systems pivotal for space-bound applications. Nimel's research has been internationally recognized, with his findings presented in peer-reviewed scientific journals and global scientific conferences. Nimel, thank you so much for joining us today. I can't wait to hear all about that.
Thanks, Graham. Hope you all can see the screen. Hello, everyone. I'm Nimel Kumar. I'm an aerospace engineer, as Graham mentioned. Today, I thought I'll share my brief journey in the space sector. And so I grew up in India in the late 1990s. I did well in studies in the schooling, particularly like maths and physics. So I probably around year 5, year 6, I thought I'll go and do something related to science and engineering, but I really wasn't sure which particular area to go into. And so I think 2 incidences really influenced me in pursuing the direction of going into aerospace. I thought I'll share them with you along the way. So the first thing was in 2002, there was an Indian aerospace scientist. He became the president of India. So India had a space agency. It's called ISRO, Indian Space Research Organization, and we have been doing a lot of interesting things there back home. And that includes recently landing on the moon, on the dark side of the moon. So he became the president in 2002, and that was quite an inspirational moment, reading about him in the schools, listening to his lectures. It was really fascinating, and that was one of the first moments that I got piqued by space as a career pathway. And again, in the next year, in 2003, I'm not sure how many of you have come across this, but in 2003, a NASA space shuttle called Columbia exploded when it was returning from the International Space Station. And it killed on board around 6 astronauts, and one of them was also from India. Her name was Dr. Kalpana Chawla. So that was a big news back then, and that's how my interest in space got further accelerated. Space became something a challenging and an interesting environment where a lot of things could go wrong. You don't know what's out there, and that adventure kind of piqued me. So I looked at ways I can get involved in that field. And then towards the end of my school years, around year 11, year 12, I wasn't sure which direction to take, and I reached out to a lot of people, including some of my relatives who have been into universities. And I got some advice early on as to when you start university, perhaps it's even though you want to be in the field, start somewhere broader so that you can explore what's out there for the first 4 years of your university. And then if you like it, then you can further specialize in the field and narrow down on a specific aspect. So that's when I thought I'll take up mechanical engineering as my undergraduate degree. and I studied at a university called Anna University in India. And after 4 years, I did a lot of stuff related to aerospace, like aero modeling, water rocketry, and things like that. And when in my final year of undergraduate, I got an opportunity to work at a water treatment industry as a graduate engineer, and that involved making a lot of pressure vessels. In water treatment plants, you would see a lot of pressure vessels being used to, force water through filtration equipment and filtered water. And so I got to design some of the pressure vessels that were being used in the water industry. And even though it was a different sector, it gave me a good understanding of the fundamental concepts that are involved, and how different industries work in designing structures. And my mentor in the company suggested me then to look at international opportunities, and how I can pivot and go back again into the space sector. And so then I started applying for universities, and I got into the University of Nottingham in the UK. So I did my master's there with a full scholarship, and I specialized in composite materials. So pressure vessels are predominantly in the water industry, were mainly made of steel alloys, but composites are much lighter, and those are the materials that are being used in aircrafts as well. So carbon fiber bikes you might have heard of. So similar materials are being used in the aircrafts as well. So that's what I studied in my master's. And that in both my bachelor's and also in my master's, I also had opportunity to do some thesis and research. And that really interested in me, and I wanted to pursue a research career after that. So I started applying for PhD programs, and I got an opportunity to do PhD at UNSW in 2017. Then there was a delay in the visa process, so things don't turn out the way you plan to, and so I had to pivot and work for a small amount of time, like about 6 months, at a startup called the System Controls. And again, I had an opportunity to do some cool aerospace work related to onboard radar tracking systems. So basically, every aircraft or a satellite would have radars and various kind of sensors to track objects, or even transmit signals from via antenna. And so I got to design some of the tracking systems for those radars. And then the visa came through, and then I moved to Sydney to do my PhD along with Boeing. So Boeing is an aerospace giant. They are in wide fields. You might have flown in some of their aircrafts. They're also into space launches, satellite and rocket manufacturing as well. So I worked with them on some computational modeling aspects related to composite structures. And that's when I got to use some of the machine learning techniques. So kind of can see, even though you work on one aspect, you get to, the more you specialize in a field, you get to use techniques or tools from other fields. And I got to learn more about machine learning during my PhD. And towards the end of my PhD, I got an opportunity to again go back to industry, and that's where I'm at the latest. So I'm now working as an aerospace engineer, designing composite tanks. Again, these are lightweight carbon fiber-based tanks that are used for hydrogen storage and other cryogenic fluids. So you can kind of see that the career pathway hasn't been quite linear, unlike Laura's. So I went to university to do my bachelor's, and then came back to industry, went again to university, came back to industry. And so it kind of, it's a zigzag path. It's never linear, as could be in some cases. So one thing that, looking back, I think I've really taken home is you can never plan things ahead as much as you want to. It probably won't turn out the exact way. So you always have to be interested, have your mind open for opportunities that are in the periphery of your field, and pick whatever that comes to you, and then you can pivot along the way. So that has been my journey, and I look forward to having some more chat in this direction. Thank you.
Awesome. Thank you, Nimal. That was fantastic. I particularly love you talking about your journey being very non-linear. I really love that non-linear journey. That's fantastic. And particularly you talking about your heritage and your passion for your job coming from that history from your country. So I thought that was really fantastic. So thank you so much for that. That was beautiful. I hope we can talk more about that in the Q&A in a minute. And last and not least, we have our final presenter for today, Dr. Lucy Foreman. Lucy is a planetary geologist at Curtin University, and she's in both research and teaching in the School of Earth and Planetary Sciences. And she's also a research associate at the Meteoritics in Western Australian Museum, which sounds really fascinating. Lucy looks at rocks from space, primarily those from the asteroid Vesta and the surface of Mars, to learn about our solar system's origins. Lucy is also the unit coordinator and lead lecturer for the first-year planetary science course taught at Curtin University, and is a strong advocate for reaching communities far and wide via science outreach. So you're certainly welcome here at ATSE, Lucy, and thank you so much for presenting today.
Thank you very much for having me. Thank you for that slide. So my name is Lucy. So I want to take you through my journey of where I've come from and essentially what I do now. So it has a little bit of a different flavour to my co-presenters in that I look at rocks. And most of my journey has always involved rocks, but it's sort of changed a little bit over time. So you might notice that I don't have a particularly Australian accent, and that is because I grew up in the UK and I lived there for the first 23 years of my life. So I always really enjoyed like science and maths and geography in school because they came quite easily to me, whereas things like English I found a lot more challenging because it involved a lot more sitting down and writing. And what I've learned as an adult is actually that I have ADHD, so kind of that tracks. So the ways that I've adapted how I do my learning and things like that are mostly because of that. So because I enjoyed those and because they came quite easily to me, my geography teacher suggested to me, hey, maybe consider doing geology at university. Because of where I grew up, it was quite a small town. We had very what are called traditional subjects, in that it was sort of your core science, core maths, geography, history, nothing sort of out of the ordinary. So I didn't even know what geology was. Had no idea if I'd enjoy it, but I managed to get into Imperial College in London, and I did geology and geophysics there. The neat thing about UK universities is that a lot of them offer undergraduate masters. So I did 4 years of undergraduate study and came out with a master's, which is kind of the cheaper way to do it, from what I gather. But that basically meant that I did 3 years of normal undergraduate, and then I did a year of research at the end of that to come out with my master's. Now, what I should mention is when I was a kid, I would always go, we would go on holidays as a family, and we would just go around the UK, stay in little cottages, and we always went walking. And I loved the hills. I loved looking at the landscape. It was fascinating to me. And so that's one of the reasons why I decided, yes, let's go and do geology. So off I went to London, which was a massive change for me, because I'd grown up in quite a small town to all of a sudden be in a city where it felt like the universe lived. But that was pretty fun. So after my 4 years of doing that, I actually got to do a little bit of everything. So I did geology and geophysics, which meant that I took units from the 2 different degrees. I sort of cherry picked what I wanted to do, which ended up being that I was a jack of all trades and a master of none, which is fine. It meant that I got to try lots of different things, but everything kind of felt a bit challenging to me because that wasn't the sort of one thing that I'd really gotten myself into. But one of the cool things was I got to do a planetary science course in, I think it was the end of my 3rd year, which was an intensive 2-week course because it was in the summer and that's how they do things. And I thought, right, this is what I want to do. This sounds really cool. I've really enjoyed this. let's go. And when I finished my degree, one of my lecturers at Imperial College offered myself and two of my peers a PhD with him, with the caveat that we'd have to move across the world. And of course, that's not exactly the worst thing in the world. We were all extremely excited to head off down to Perth. And that's where I've been ever since. So I've been here for 10 years. So I did my PhD. That took me 4 years. And I looked at meteorites doing my PhD, lots of different kinds of meteorites. I was able to go to conferences all over the world, meet specialists from lots of different areas, all working on meteorites, and general space science as well. I got to be one of the first people, or the first person, to publish some really cool images of meteorites that had never been created before, which is really exciting. I got to go on meteorite hunting trips. So across the Nullarbor Desert, we would go and look for meteorites, which was always really fun. There would be sort of 8 to 10 of us just out there for 2 to 3 weeks in the desert. It was just really lovely, really different experience. And I'll always be really grateful that I got to do that. So once I'd finished my PhD, I then was fortunate to be given a position as a full-time researcher at Curtin, which is really awesome. I get to work with the same team. I now, in a similar way to Laura, I have students of my own, and watching them succeed and helping nurture their interest has been really, really rewarding. So I'm still working on meteorites. Primarily at the moment, I work on meteorites that have come from Mars and from the asteroid Vesta. And the things that I'm actually doing with those rocks is figuring out how they formed. The neat thing with rocks, any rocks from anywhere, is they tend to record what's happened to them. So we just need to figure out how to unlock those secrets that they're holding. And really, they have a really awesome record within them. So what typically would happen, we have a rock that would come through our atmosphere. So we might call that a falling star or a shooting star, or a meteor if we want to be more technical. Then that rock lands on the ground. So I mentioned that we went to do meteorite hunting. So we'd find a rock, think it's from space, take it back to the lab. We'd typically slice it open. Firstly, make sure it is actually a meteorite, and not kangaroo poo, which is a common problem out in the Nullarbor. And then my job as a planetary scientist, planetary geologist, is to go in and look at the really, really, really tiny scale individual grains. Now, they could be the size, the width of a human hair. They could be really, really tiny, or they could be the size of your pinky fingernail, perhaps. There's a lot of variety there. So until we put it in a microscope and have a really close look at it, we don't really know what we're looking at. And that's one of the things I find so exciting. You might find a rock out in the Nullarbor, but you're not really sure what it's going to tell you until you really look up close. And so then that's when we figure out, where has this come from? What is it made of? And what does that mean for what's happened out there in our solar system and what might happen in the future? I'm also fortunate that I'm able to do some teaching to first year geology students and engineering students. We typically have around 120 students, so they definitely keep me busy. But I thoroughly enjoy teaching. I think it's great to demonstrate that there's various flavors of geology available to work in out there. And I also love being a STEM advocate. I really enjoy doing outreach events, doing public talks, going and representing Curtin or the WA Museum at expos, for example, and really igniting passion in other members of the public, be them young, old, from whatever background. I just enjoy making science and planetary geology accessible to pretty much anyone that I meet. And it's a pretty cool field. So a lot of people tend to be quite interested without me having to do all that much work to get them there. So that's me pretty much. I do really enjoy doing science with my kids as well. And I've gone into my kids' nursery to do a little space science. I took meteorites to them a few weeks ago, and they all came out in one piece. So I was quite impressed, given that they're all 3. So yeah, that's me.
Fantastic. Thank you, Lucy. I'm now going to be distracted every time I go for a bushwalk, wondering if it's a bit of kangaroo poo or if it's a meteorite from Mars. Must be a fun thing for you to try and sift through. Fantastic. So all three presenters, that was excellent. We've got about 10 minutes now to have some Q&A. So the first question I'll pose to each of you, and I'll just remind everyone who's attending today, if you've got any questions for our panelists, please put them in the Q&A chat. As a teacher, one of the things that I always ask presenters to talk to high school students about is, what do you think is the most important thing to focus on when you're in high school? And obviously, we're looking at space science today, so I'd pose the question to each of you, thinking about, keeping options open as students move into year 11 and 12 in uni. And I know a lot of you mentioned that your paths weren't very linear and you didn't really know what you were going to do until you stumbled on it. So I might start with you, Laura, if you could answer that question for us. What do you think is most important for students to really focus on in high school if they think that they might want a career in space science?
I would say the most important thing is to remember that being a scientist is about asking questions. So foster your curiosity and I know it can get a bit overwhelming with the syllabus telling you need to learn this, but nowadays there's so many resources out there. Go on YouTube and pursue something weird and wonderful just because you can. And asking questions as you're going, why is that happening? What about this? What about if we take this and put it together? I think that's learning how to ask questions and continuing to ask questions is really, really important. I guess on the subject level, I'll be traditional and go your physics, chemistry, maths. Maths is really important. And I would say now, get yourself a bit of data science, get yourself a bit of programming. You can definitely pick it up later, but a bit of Python's going to help you so much in your career wherever you go. Python's just one of the languages you can use. It's the most common. Yep.
Yeah, fantastic. Great advice. Namal, how about yourself? Obviously, you studied over in India before moving to Australia, but what do you think, no matter what country students are from or what background they're from, what do you think is most important for them to really think about or focus on when they're younger in terms of getting into a career like yours?
I resonate with many of the things Laura mentioned. Learning programming early in your career, I think it will open up a lot of pathways. But one thing that I have learned is explore before exploit. And so within space itself, there are so many things. One of my passions when I was struggling to decide between what to go choose in undergraduate was between computer science and aerospace. I was really good at programming as well back then, but I just wasn't sure like which one to go. So what I did was just took what I could only do in university. Programming could be done. You can just pick up a book or watch YouTube videos and learn, whereas you can't learn some of the hard sciences without going to a proper, structured program. So that helped me take the decision. So I would say, think about these aspects and also, broader allied aspects related to space. Be it, you have Laura and Lucy working on some geology aspects and astrophysics and things like that. So there's so many other fields that are in the periphery of space. When I was there looking at it, all I knew was aerospace as an engineering subject, whereas you have all the sciences that are coming into the picture these days. And with the space opening up to commercial entities, there's so much out there. So yeah, be interested in other aspects of science.
Yeah, I think you hit the nail on the head there. Sometimes there's so many options and students don't know what's out there. So, being curious and that is fantastic. Lucy, how about yourself? What do you think is really good for high school kids to focus on moving into careers in space science?
Definitely keep your eyes open. I think consider as well what environment you want to work in. So when I was thinking about university, I was like, geology, medicine, very not similar things. But my mum actually pointed out to me like, hey, do you want to work in the same place every day, or do you want the opportunity to go out and explore and be outside and do the kind of things that I really liked when I was younger? And so I thought, yeah, actually, I do want to go outside. I can't see myself working in a hospital or working in a healthcare setting that I don't get to travel doing. And so this is really the kind of space I want to be in, pardon the pun. So I think also considering that. And in school is incredibly important. And there's also education that you can do outside of school that can enrich what you do in school. I think when I was younger, I always thought school's really important. School's the be all and end all. I have to do really, really well in school. I'm going to do this because it's going to help me do really well in school. When in reality, what I should have thought of is, hey, I'm going to do this because I love it. I'm going to do this because it ignites my passion. Sure, it's going to help me in school, but that's not the motivation for me doing it in the first place. So I think having that mindset has also really helped me as I've gotten older, because I left school and all of a sudden there wasn't this linear pathway in front of me, and I wasn't sure how to make those decisions according to what I wanted, because in the past it had just been, well, this is just what you do. This is what everyone does. And so then I thought to myself, yeah, I need to figure out how to know which direction I should take my life and my career according to things that I love, and things that I'm fairly good at too. Helped.
Awesome. That's great advice. I might open this next question up to all three of you and see if any of you have got an answer for me. So obviously, I think every field in science is.
I can't hear you. Oh, you've gone on mute, Graham.
Oh, I'm unmuted. There we go. I'll try again.
Sorry.
Obviously, the careers in space science are changing quite a lot, and technologies change every day. So a question I thought I would ask to all three of you is, what things are you excited for? What new technologies do you think are coming up that'll really help you? What new jobs in space science do you think are coming online that might be really exciting? And whoever wants to go first.
Oh, well, I mean, I guess, well, in the Australian context, we've got the Square Kilometre Array coming up. So we're going to have half of the world's best radio telescope, and Australia is Southern Hemisphere. Yeah, it's over in WA. It's going to create huge job opportunities over there. Yeah, and I mean, you can see it's not affecting Australia as much, but the James Webb Space Telescope, which is the big observatory that just launched Christmas Eve 2021, has just revolutionized the field of science, the astrochemistry and astrophysics that I'm associated with. And the Square Kilometre Array will do the same thing on a very Australian level in a couple of, I think about 5 years, maybe 10. It keeps on changing, but soon. In this audience's early career. You're on mute, Lucy.
There we go. Thank you. I'm personally really excited for getting some samples from the asteroid Bennu. So we at Curtin, we have huge amount of analytical equipment to looking at all these different levels. So we can look at, obviously just a hand sample, but we have an atom probe here, which means we can look at individual atoms. So that's pretty neat. And we're getting some samples from NASA from the asteroid Bennu, should be arriving fairly soon. So I'm pretty excited to dig into those and see what that's about. And I think that sample return is going to become a lot more common now that we've got JAXA, who's done it twice. We've had NASA do it. I'm sure other nations are going to get into things as well. So I think sample return mission is really going to provide a lot more context to the science that I do. So that's really neat, and that will be within my career. So that's kind of exciting. I would love to have like a little microscope, a tiny microscope on a rover that goes to Mars that can tell me the information I need, because right now rovers aren't there yet. But hopefully they'll get there.
Yep. And obviously bringing stuff back from other planets to have in your own lab is super fascinating. We need aerospace engineers to do that. Namal, what's exciting in your space do you think is coming up in the next few years?
They have been talking about the payloads that are being taken up there to do all the sample return and putting kilometer arrays. I'm really interested in the cost reduction of space transport as such. We've got reusable re-entry vehicles, so the number of space launches have increased dramatically in the last few years, thanks to companies like SpaceX, and we have many other companies in Australia as well. So the space is becoming more accessible, and at a cheaper cost as well. So that enables many of the the challenges that are out there in sciences, and it enables us to understand the universe and also the Earth much better. So I'm really passionate about that.
Yeah, fantastic. That's excellent. Well, I think we can see that there's so many options for students and so many pathways, and I could see all your faces lighting up talking about what's coming up in the next 5-10 years. So for a lot of the older students that'll be watching us, that'll be right around their time where they're doing their honours, masters, or PhDs. So exciting times ahead in space science, which is fantastic. Look, that's all the time we've got today, unfortunately. We've got to let people get back to their busy lives. But I wanted to thank all three of you so much, Laura, Nimal, and Lucy. Thank you for giving us your time today to talk to us about your careers and your journeys. I certainly found it fascinating and inspiring as well. So hopefully some of the people watching either live or watching in a few weeks' time on YouTube will really appreciate it as well. Obviously, thank you all in the audience for joining us today too. Whether you're an educator in a classroom or taking 10 minutes out of your day in the staff room to have some lunch and watch at the same time, we really appreciate you coming along. As I said, this will be recorded and put up onto YouTube. So if you've got any other students or colleagues that you think would benefit from hearing from these amazing stories today, we'll make sure we share that through ATSE's social media so you can push that out as well. We will be sending out a survey to everyone who's registered to attend today, so we'd really appreciate if you could take a couple of minutes to fill that in. We find that feedback really valuable for us to help make these sessions as beneficial for you as we possibly can. And our next Shape Your Future session is going to be in late November. We're going to be looking at digital technologies, cybersecurity, and the future of Australia. So it should be a really fascinating topic. So thank you once again to Laura, Nimal, and Lucy for your time. Thank you for everyone joining us, and we look forward to seeing you next time.